Hi guys, the video stopped on its own before, so instead of starting it all over again, I thought I would just come over here and pick up from where it ended. So it said that, we want to get to $9,110. What would the rate be in 30 years? So we divide by the 5,000, and then we have 1.822 equals E raised up to the 30R. Now we need a natural log on both sides. Now a natural log on an E, they cancel, so down drops the 30R, and the natural log of 1.822 is 0.59934. We're going to divide both sides by 30, and we get an interest rate of 2%. So now, number 3. A population of rabbits is doubling every 60 days. Now, when you're doubling every 60 days, if you recall, this is when you would need to have 60 days, 60 over 60, just to double once. So that's why we have the division here. Now, they want us to solve for time, the initial amount of rabbits. How long does it take to get to 320? So from here, on number 3, we have to divide both sides by 10. And now we have 2 raised up to the t over 60 is equal to 32. So you could do this one of two ways. You could go back to exponent and say, hey, wait, I know 32 is 2 to the 5th power. And if this side is 2 to the t over 60, then you can have t over 60 is equal to 5 over 1, because if everything's equal and the bases are equal, the exponents are equal. And then you can use cross product and find that the time is 300 days. Choice 2. Also, from here, you didn't have to use exponents. You could have used logs, and if you used a log, it would have brought this down in front. T divided by 60, natural log of 2 is equal to the natural log of 32. You could have divided both sides by the natural log of 2. And I think you already know what you're going to get. You're going to get 5. And t over 60 is equal to 5. So again, t would have been 300. So you could have done this problem either using exponents or using logarithms. And it's always good to know both ways, because the more work you know, the better, the more options you have. And before I erase this, let's just take a look at number 4. The growth rate of bacteria in a dish is modeled by, I'll use a different color so this way we know the difference between these 3 problems. This f of t, so this is number 4. F of t is equal to 2t divided by 3 power. And now they want to know the value of t when f of t is 32. So now I have 2 to the t over 3. 2 ways again. Use your logs. We just said 32 is 2 to the 5th. So we could say 2 to the 5th is 2 to the t over 3, giving us 5 equals t over 3. Put this over a 1, solve proportionally, and you get t equals 15. Or you could have put a log on both sides. Either way, you're going to get the same answer. Number 5, we're going to have a word problem, and it's compounding continuously. And notice that those big word problems could also be given to you as a multiple choice. So here's where you have to really just take your time and make sure that you do every step. Even though it's multiple choice, you do every step. When you're doing every step, you can eliminate from the work you're doing what doesn't make sense. Don't ever look at the answers and think that you can eliminate work without actually doing something first. So let's start with this one now. Okay, so number 5 rather. Susie invests $500 compounding continuously And so the formula's on the board. The interest rate is 5%, and we want her money to double. Well, if you're investing $500 and you want your money to double, then that means you want $1,000 from your $500 investment, and you have a 5% interest rate, and we're looking for the time. So we're going to divide by 500. And this is going to give me 2e to the 0.05 to the time. I'm going to put a natural log on both sides. And when I put the natural log on my e, they're going to cancel. And now the natural log of 2 is equal to 0.05 times the time. On my calculator, I am now going to type in natural log of 2. I'm going to divide it by 500ths. And I am going to find that my time is approximately 13.9 years. Choice 3. Number 6 is another word problem that they had put on part 1 for the regents. I'll use a different color so we can do both on the same page. It says Akeem invests $25,000 that pays 4.7% annual interest compounded continuously. So this formula again. And we want to know how long it's going to take for his investment to triple. So if I'm tripling and I'm starting with $25,000, then that means we want $75,000. And again, the interest rate was 475, so 0.0475 times the time. So when we divide out the 25,000, notice we get 3. And that's, we wanted the money to triple. Here, when we divide it by 500, we got 2, and we wanted the money to double. So that's another little check. I mean, if you've picked up on that, wonderful. That helps you see if you're on the right track or not. So now again, got to add a natural log on both sides. And the natural log and e are going to cancel. So now if I take my calculator and I have the natural log of 3 and I divide it by the 0.0475, that's going to give me the time. And when I do that, I find out that it is 23.13, which was choice 3. So that was number 6. Number 7 is talking about is New York State's minimum wage growing exponentially, and the time begins in 1966. So that's my time 0, 1966. This one's not using continuous, so we're going to get rid of the formula. And we'll write down the formula that we're going to need for this particular problem. So this one, in 1966, the minimum wage was $1.25, and in 2015, it's $8.75. So 1966 is time 0, and minimum wage was $1.25. Then we jump all the way to 2015, which now tells us that the time is 49 years. All right, so if you want, you can pause the video at this point and you can check from 66 to 2015. You get your 49 years, and that now the minimum wage at this time is $8.75. So, according to this problem, they want us to just figure out the percent. They don't give us any kind of information, continuous, compounding. So when that happens, we have to go with yearly. That's, so we're going to have to assume yearly. So we are going to be using the amount over time is equal to the initial amount, 1 plus the rate raised up to the time. So the original amount was $1.25. The new amount was $8.75. I don't know what the rate was, but I know the time was 49 years. So I look at this and I have 875 divided by 125 gives me 7. And then that gives me my 1 plus my rate raised up to the 49. So I didn't write this out, I probably should. And I want to cancel out an exponent, so this is going back to the exponent work, reciprocal again. These are going to cancel. Now I get my 1 plus my rate dropping down. 7 to the 149th power is 1.0405. So I minus the 1 from both sides, and I find out that my rate is about nearest percent, which would be, looking back here, 0. My rate would be 4%. So that was number 7, that one on the regents. This was not short answer. You had to show me all the work. Number 8 is another one that is not short answer. A house purchased 5 years ago for $100,000 was just sold for $135,000. And assuming growth, exponential growth, and they want an annual growth rate. So again, same formula. We're bringing the same guy down to this problem now, which is problem 8. And the house sold for $135,000. It was originally purchased for $100,000. And I don't know what the interest rate is, so 1 plus the rate. And it was held for 5 years. So you're dividing out your $100,000. And your growth rate, your 1 plus your percentage to the 5th power, is equal to 1.061858759. So that should be on your calculator. We want to cancel out an exponent, so we use the reciprocal. There, it's gone. Now this side must be raised up, so on your calculator you should just hit the exponent and then put in your 1 divided by 5. And this now gives us a growth rate of 1 point. Oh shoot, I wrote this backwards. This was supposed to be down here. I'm sorry, I'm copying my work. I didn't use the calculator to try to make it easier. This here was 1.35 to the 1/5. And now we have our 1.061858759 minus the 1 from both sides. And you get 0.06185. But they said to the nearest percent, so the decimal moves in twice, you're looking at a 1. So this is a 6% interest rate. Sorry about that. And hopefully, can you see that whole thing? All right. Didn't realize the camera slid down a little bit. There you go. So if there's any question, you gotta let me know. Hopefully this is answering your questions on this. That brought us to 8. Number 9 is a really, really big problem. I am definitely going to need to have this whole board for number 9. Again, hopefully you are stopping the video, you're doing the problem yourself, and then you're checking, or maybe you're getting stuck, so you're gonna watch till you get unstuck, and then let's see what happens from there. All right, let's just make sure my board is nice and steady. All right, so you got this big, big formula on this one. I'm not gonna read the whole thing. We're, cooking a turkey. So the time or the temperature, T of A plus T of 0 minus T of A, and E to the negative K and the time. So the T of A is the temperature surrounding the object. T of O is the initial temperature. T is the time. T is the temperature after how many, the T hours, and K is the decay constant. That is a lot of information in this problem. It says a turkey reaches a temperature of approximately 100 degrees Fahrenheit. Well, if that's the temperature it reaches, here's my 100-degree Fahrenheit. Okay? Don't even really need the degree here, but then it says, find the value of K. So now I know I'm looking for this guy up here. Here's what I'm going to be looking for. That's my unknown. To the nearest thousandth, 3 decimal places, and write an equation to determine the temperature of the turkey after T hours. Okie doke. So you go back to the original problem. After sitting in the refrigerator for a while, a turkey is at room temperature 68 degrees. So here is the 68 degrees. It's placed in an oven at 8 a.m. when the oven temperature is 325 degrees Fahrenheit. Now 8 a.m. is time 0. 8 a.m. equals time 0. And Newton's law of heating explains the temperature of the turkey will increase proportionally to the difference between the temperature of the turkey and the temperature of the oven, as they gave it to us right here. Now, the turkey reaches a temperature of approximately 100 degrees after 2 hours. After 2 hours, that's 10 a.m. So at 10 a.m., that's time is 2 hours. So now I have negative K times 2. And the value of K to the nearest thousandth, all right. Oh, I'm sorry, I forgot to put my other 325 here. So when you look at this, there's only one unknown. We take the original problem, everything, it was a little bit, it took a little bit of time, but if you read it all up, if we subtract 325, we have negative 225 is equal to 68 minus 325 in the parenthesis is negative 257 times e to the negative k times 2. So now I'm going to divide by the negative 257. That's going to cancel. And I'll just put negative 2k. I'll clean that up on that side as well. And this gives me positive 0.8754868. This is on your calculator. Now what we're going to do is we're going to put a natural log on both sides. Now e and the natural log are going to cancel, so down drops my negative 2k. when I put a natural log on this number, I'm not going to write the whole thing. It'll take too long, so I'll just put 0.875, and I'll just 5. But basically brought that down. I'm going to divide both sides by -2. So I'm letting the calculator hold that, hit divide by -2, and I get 0.066487 equals K. So K to the nearest thousandth, 3 decimal places, 0.66. Because again, you are looking at the 4. So now I know what K is. Now they want me to find the temperature of the turkey at 3 p.m. Well, again, we had to go back to our beginning. 8 a.m. is time 0, and now if I'm going to go to 3 p.m., that's going to take me 7 hours. So from 8 all the way around to 3, 7 hours. You can even count on a clock. So now part B, which I'll do in a different color so that this way when you're looking at it, hopefully it'll be clear. So now what I have is the temperature. The surrounding was 325. And then I have my 68 minus my 325, E. And I have -0.006 times 7. So this one now, we just have to type in. So this temperature is 325. And remember, this became a negative number, -257 E to the -0.006 times 7. And you could just put this straight in on your calculator at this point. I mean, that's what I would do. I would just type this whole thing straight across. And what you're going to end up getting is 163.0842586, which means your temperature is roughly 163 degrees Fahrenheit. And you still need about 2 more degrees for your turkey to be completely done. You don't want to serve anything undercooked. So that one was pretty rough. That was a part 6. And they haven't really given one this rough in a long time, but you never know. So just always make sure that you take your time. You highlight what each number is so you can plug into the formula carefully, and you should be okay. Remember, the rules of algebra are not going to change. Doesn't matter what you're doing, the rules of algebra will not change. So now let's take a look at number 10. You're starting with the population of bacteria at 100. It will be doubling. If each period is 15 minutes long, how many minutes will it take for the population to reach 51,200? So they're telling you to use this formula for number 10. They're telling you to use 100 doubling over time. And again, you're starting with the 100 and they want you to reach 51,200. And if you divide out your 100, we're saying 512 is 2 to the t power. So you can use logs or you can use exponents. If you use logs, and we put the natural log of 512, and we get t times the natural log of 2, divide by natural log of 2, you're going to get 9. So it took 9 periods of time. See, this one, the wording was really tricky because they said now each period of time is 15 minutes long. So now if you have 9 periods times 15 minutes per period, you are going to have 135 minutes. A little tricky. Again, a lot of times it's all about the grammar, making sure that you fully understand the problem. Number 11, Drew's parents invest $1,500 in an account, and they give you this equation, which means that it's going to double every 7 years, and they want to know how long until it reaches $100,000. Well, number 11 now, I want $100,000, and I started with 1,500. I know my money is doubling every 7 years. So I need 7 years over 7 to be an exponent of 1, and then my money will double. How long is this going to take? Well, I'm going to divide out the 1,500. And I am going to get 666.6 repeating. And guys, this is why it's so important to keep the numbers on your calculator or repeating decimal. Just let your calculator hold on to it and then use that number. Now we're going to put a natural log on both sides. And again, you can just put second answer, which is exactly what I would do here. Natural log, second answer. And then the t over 7 comes down in front with the power rule, natural log of 2. So if you have the natural log of the answer, and now you divide this by the natural log of 2, and hit enter, your calculator is going to give you 9.3808217884, and that is your time over 7. So you want to cancel division, you're going to multiply by 7 on both sides, and you're going to get 65.7 years. So when you round, you actually got 65.66575. You got to round, you get 65.7 years. Only 2 more problems, and then this packet is done. And then you will have the entire test review to do all on your own. So if there's a problem on the test review that you don't understand, then you should always go back to any of these videos and look up a similar problem. Sean invests $10,000 at a rate of 5% compounding continuously. All right, so number 12, we're back to the PERT formula. And his investment is $10,000. And we want to know to the nearest dollar the amount of money he will have in 2 years at 5%. What amount will he have? You type that in, and you get $11,051.71. They say to the nearest dollar. So $11,052 would be to the nearest dollar. So that was part A. Now part B, we want the money to double. So now we want 20,000 over here. The rate is still 5%, but now we need the time. So just like the problems before, I said, look at what happens. If I wanted the money to double, there's my 2 for doubling. And we're going to throw a natural log on both sides. And when I do that, natural log of e to the 0.05t, these guys cancel. Natural log of 2 is 0.05 times the time, divide by 0.05. And you end up with 13.8629, and it goes on, but I round it. And then they say to the nearest year, so 13 looking back at an 8, 14 years. Okay, so number 12 had 2 parts. This would be, you know, the 6-point problem on a regents, especially because it had the 2 parts. Last one, nope, almost the last one. Number 13, bacteria in a Petri dish again. They love the bacteria problems. So let's take a look at that one. Okay. So the number of bacteria is given by this formula. You have n is equal to 50 e to the 3t, and now they want to know about 30,700 from the 50 that you had begun with. Divide by 50, and you have 614 equals e to the 3t. Natural log is 614. I just went right to the power rule. These guys are going to cancel. And so now I'm going to divide by 3. And we find that it took 2.139998, so roughly 2.14 hours. And they want a solution for 14 to this equation. So number 14, 8 times 2 to the x plus 3 is equal to 48. Now I would divide by 8. And I would have 2 to the x plus 3 is equal to 6. And so now what I would do is put a natural log on both sides. So if I have the natural log of 2 to the x plus 3 equals natural log of 6, power rule, the x plus 3 is going to come down in front, but the x plus 3 was the whole exponent, so keep it in a parenthesis. Natural log of 2 is equal to the natural log of 6. Now we're solving for x. So the first thing I'm going to do is I'm going to divide by the natural log of 2. And here I now have x plus 3. I'm just bringing this up so I can fit it. Natural log of 6 divided by natural log of 2. And if I want x by himself, I'm going to minus 3 from both sides. X is equal to the natural log of 6 divided by natural log of 2 minus 3. Choice 1. So there you have it. This was a long video, but it was a long review sheet. Again, I really do hope that you did the problem yourself, pause the video, and then check to see that you did it right. And so now the test review is up. The answers are up. Make sure you're doing your review sheet. Make sure you're studying, because on Friday, April 3rd, I'm putting up your test, and it's only going to be up on Friday for a short amount of time. So you should absolutely be checking the Google Classroom. All right, have a good day, and I hope everybody is well.